I was hoping this was going to be a quick one, but it turned out not to be a quick one. This is a joystick, zip stick off eBay, and it was sold as not knowing whether it works or not. Plugged it in, it all worked apart from the up. And these things are pretty simple affairs. What you got in here is you've got micro switches, and those micro switches basically sit in like that, and then when you move the stick, it clicks the switches. So test the switches. So these are normally open switches, which means they're open until the button's pressed, and then they're closed. So the top one's normally ground, and then you've got the normally open one, and then you can see the normally closed one's been cut off. So this was basically wrapped with wire. It wasn't even soldered on the ground, so I've redone that with some what do you call it, enamelled wire. So it looks bare, but it's actually insulated, and it's far enough away from the other pins. How these things work is you've got the ground plane, and then all of the correct me if I'm wrong here, I might be, but all of the signals like up, down, left, right, etc. basically send the voltage. So they're normally high, and they get pulled to ground when the button's pressed. So that's if you had, that's the wrong way around, but if this was ground and this was 5 volts coming in, pressing that button just grounds the 5 volts, and then it knows that that button's been pressed. So all of these switches worked. The next thing to do is to make sure that signals are actually going down the cable and reaching the end of this. And you can do this a couple of ways. You can either stuff a bit of wire in and measure continuity between the bit of wire and the appropriate pad, or if you've got bits of junk lying around, you can get a port, like I've got a port here, and just smash that on the end and make it easier. And I always try to imagine how the connector looks. So this is looking at the computer port, so if you were looking from outside the computer, this is what it would look like. And then this one underneath, let's get this connector back off again and throw it on the floor, is looking at the connector like that. So it's a D sub connector. It's got 9 pins, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you imagine you pick this connector up and turn it over, it would make with the computer like that. So just to get your head straight on which pins are going where, I like to do that just so I don't screw it up. And what I found is basically they were all showing continuity apart from one. Observant amongst you would have noticed that up is 1, up doesn't work, so 1 doesn't work. And that's where we got the problem. So I looked at the cable and I thought, okay, where they normally break, and I hated cutting the cable, is here. They normally break here, like headphones or any power connectors. If you've got one of those wall warts, as they call them in the US, or a pair of headphones where you take them out, you wrap them around the phone, and then one day one of the headphones don't work, it's normally because of metal fatigue. You're bending this backwards, forward, backwards, forward, backwards, forwards, eventually something gives. So it's more likely than not, if you've got something that's got one of these on, this is a good place to start. So I cut that as short as I could, thinking this is the bit that don't work. And I was wrong, this bit does work. So now I've got a cable with this on the end of it, and there's no continuity between this and the cut end of the cable that's still long. And I'm thinking, okay, well, if I'm going to need a new cable, I want at least enough length here to be able to keep this connector, because I don't have one. So I cut this to a reasonable length, and that still shows continuity all the way through. So I thought, okay, I'm losing my mind, I'm going to bed. I woke up today and I thought, I know what I'll do. I'll go and nick the alligator clips off the power supply. I'll strip the cable down, the one, which was the white. Strip it back, I'll put one end on each, continuity, nothing. This whole cable, all the way along, nothing. I thought, I'm going to cry into my beer if I find out it was only a small bit of cable, so I cut a little bit off. Still no good. Cut another little bit off, still no good. Cut another little bit off, each alternating end. Another little bit off, ridiculous. I'm going to end up sitting about a foot away from the computer thinking, I wish I'd used a new cable. So this cable is definitely out of the running. What can I use to replace the cable? And then I thought, I've got a broken HDMI cable, because I'm the sort of idiot that keeps broken HDMI cables, and the reason I do is that I can plug that end into a HDMI port, and then I can run a meter across this end and see whether it's actually reading. So what I'm going to do, I'm going to cut this, so I keep the connector for my testing, and I'm going to use this cable. This is what we're dealing with. We've got the shielding off it, there's sort of foil around it, and then I've twisted the grounds together. I'm going to use that as ground just because it's like shielded with wire and foil around it. It's difficult to focus with only two hands, but you've got 3 of these twisted pairs inside the shielding, so they're shielded inside the shielding, and then 6 of these little wires. So 6 of these little wires plus the ground is 7. That's enough. And I leave these twisted pairs for strength as a sort of a core to it. And it just occurred to me, network cable might have been a better idea, but I don't have any network cable that I want to butcher, so this was already broken. See if it works. I don't know what I'm biting off here, but this is how I'm doing it. Basically trying to join each one of these up by shoving them in and then feathering them together and twisting them together and then soldering them. So that's the soldering job. It was a nightmare. And I'm leaving these at the moment, these the ones sticking up here and these others. Don't use them, but that is the soldering job. Now there's some sharp bits sticking through some of the heat shrink. So what I'm going to do is rewrap these again with something else, and then I'm going to seal it all up and plastic dip it, and then put heat shrink over the top. I've just checked continuity between each one of these. Focus, focus, focus. Each of these and each of those. Now it works. Basically stuffed it up with plastic dip inside, put another couple of jackets around where it was poking through so it can't short. So there we go. It's not the most pretty thing in the world. I'll try and get it to focus. But that's 2 layers of heat shrink with plastic dip inside it, which goes off like plastic or like rubber, and then a splint shoved down between that and a 3rd layer, one each side, which is just a bit of cable tie like that, which is just take the whip out of it, stop it bending at an extreme angle. Then I'll wrap it in electrical tape all the way along. Not pretty, but it should be a bit of a tank. I've just offered the cable up like that. You can see there a couple of cable ties, one each side, just to hold it in place. And it's got enough slack. I've also just noticed these posts all appear to be damaged. Not all of them, but most of them. So I'm going to reinforce those. But first of all, I'm going to get these switches working. So there we are. Now we've got up, down, left, right and ground. Remember that right, when you move the stick, it's going to move the bottom of the stick in the opposite direction, same as up and down. So I just tested each one with a meter to make sure it was the right thing. Now that leaves us the yellow one, which I didn't think I used, the red one, which I think is 5 volts, and the green one, which I think is fire. The description said that the Autofire button had fallen off, and it had, because it wasn't attached to this board. And what this board is the Autofire, and what it is a little 555 timer, which basically puts out a square wave and is connected back to the fire button. So it needs its own 5 volt supply, so it can basically pulse at a rate determined by these caps and these resistors. And what it's doing is it's basically grounding the fire button. If you look at the pinout, it's got ground and power. It's coming from the Commodore, and it's when it reaches a certain threshold, it sends out a pulse, which effectively grounds the fire button, which is the same as pushing the fire button. So I hooked it up to an ATX, put an LED on there with a little resistor. And if I just mimic the switch being on, you see the LED come on? Off. On. I don't know how quickly it's doing it, but it looks like that circuit's working. So I've had another look at this today, and when I went to solder these on, these little tabs fell off, so they must have been part of the old switch, which means that the rummage switch would actually fit. So that's a plus, so I'll get that on there. Okay, so that's back in and pretty solid. I'll put another screw the other side, but that seems fine. And then I was just thinking about this. This must go to the same one the fire one goes to. It's just that they've done it the other way around, so they've used the ground on the other. It doesn't matter because it's just a switch. So if I link the Autofire to the the pin that's linked to the fire cable on this switch should have the same effect, so I'll just do that quick. Okay, so obviously the switch that it had before was longer than that, but I should be able to 3D print something, just go over that and just be able to move it side to side. So finally I just printed a little switch cover out. So there it is, all plugged in. Doesn't look too bad. And does it work? Of course it does. Of course it does. There it goes. So that's working. So thanks for watching. I'll see you all later.